Hello, this is Justin and Michael of the Smart Kitchen project for EDL. Today we'll be showing you our project demonstration. So here we have our refrigerator units printed on custom PCBs. We have two of them here today. They can be powered by these coin cell batteries over here, and they also have a temperature sensor, and this one has a pressure sensor as well with this square sensing unit. So let's get into the demonstration on the Arduino IDE. Let's upload this code to our base. Pulling up the serial monitor. So as of now, these two units are not powered on, so we shouldn't see anything right now. And now let's plug in the battery. Alright, so it's plugged in. Now we should see it connect. Okay, so here we see board type fridge. The UUID we assigned it is 65, and these are the readings for the temperature, pressure, and battery. Okay, so now we have our second refrigerator unit all hooked up and powered on, and as you can see from the serial monitor, we do in fact see both of the boards. Note the UUID 64 and 65, so we have both units showing up. And to demonstrate that our data is dynamically changing, I'll apply some pressure to this pressure sensor here. So as I apply more, we should see the value increasing. See that? It goes up to over 1,000 for this board. And then when I release, it goes down to 300, 500. Okay, so it goes all the way back down when I release pressure. And so this is our Arduino shield that we made in Eagle. So we have each of the Arduino pins mapped out, and we have connectors for the Nano, the BLE Nano, which is the middle right here, as well as the XB Wi-Fi, which we have over here. But for the purposes of our demonstration, we wanted to show you the serial monitor data, so we couldn't hook this up because of the TX and RX pins. So here we have it on the breadboard. This is the scanner BLE, which receives data from the remote BLEs, and this is the XB Wi-Fi, and that transmits the data to our database.
Right, what we're doing here is that we have this separate computer which is not connected to our system at all. This wire is the only wire that is going into this computer right here, and this XB is communicating to Wi-Fi. What we'll see is that on the server, once this starts up, we'll see a response on the server that we actually sent data to the server. And again, this is coming from our BLE devices, which are again just separate from everything else. This is still working. All right. This is still doing all the sensing. Right. This is powered. Everything is there. What you'll see is that we get these 400 errors, which is the issue we were talking about before. However, sometimes we will get a full GET request, which has our data in it. So we have a UUID of the user, the board type, and the sensor values. This is the one piece of the project that is not working. Everything else, this is a plug and play. If we got this working, everything else would just be working flawlessly. Because the data is being sent, and we know this, because we know that the packet is being sent. We can actually print out the packet. All right. So this data is being given HTTP request into our database. Our database is right here. Right here's all the models to our database. This doesn't mean much to you, I'm sure, But what this means is that we can now feed this to any front-end application. So for example, we threw together a front-end application. We actually didn't throw it together, it took a long time, a lot of work. And this is our Kitchen Smart app. You see that it's very dynamic and responsive, and it took quite a bit of effort and knowledge. All right, so there's only one user. If you don't put in a valid user, then it will reject you. It will say that username does not exist, and that's because in our database, there's only there's only users that are created. So you can actually go and you can register as a user, right? Right, so this created a user called Justin. If you see before, now Justin will work right here. Now just to show you that, to prove to you that the database is actually doing something, right, let's put Ralph, let's put a password in. There's no username named Ralph. All right, let's make a user named Ralph. Let's give it the UID 4, right, Ralph Cummings, and then the password. Right, so we created a user for you. Now if we go to the home page again, right, we type in Ralph, we type in some password, it doesn't matter, right, you get your system. This shows that our database is actually updating. These are models being created in our database for the user. Each user is associated with specific boards. You can go and create your own, once you buy, like for example, you bought a board like this, each one is associated with a unique ID for that user. There's a 255, I mean it's 1 byte ID, so it's 255 boards per user, and you can have 1 byte per user as well, so 255 users. So you can 255 times 255, and just increasing the byte count there. The system is completely scalable. As you already saw, the fact that you can just switch, like I can just take this, power down this device right here, and it will keep reading, since these are just broadcasting, and this is filtering out other packets, and it won't read other Bluetooth. The fact that I plug this now in, it will just automatically recognize that this is our device, and that's due to the way that we handle filtering out other interference. All right, so now that we want to, let's show our dashboard. This is the dashboard that you would see. Now again, it's not updating live, and it's very unfortunate, but we showed you the Bluetooth updating live on the serial monitor. And again, the issue is because the one component that is broken and that really stumped us this whole time is this Wi-Fi XP component. It doesn't have a normal interaction with HTTP. But regardless, this front end is completely plug and play ready. You just pass it. I mean, this is the way that it's designed.